In this video, we will solve some practice problem about the discrete random variable and its properties. Let's say exercise number 1. If x is a discrete random variable with a probability mass function given as xk and f of xk, xk is equal to -2, -1, 0, 1 and 2, and f of xk it's 0.1, 0.2, 0.3, and the k finally 0.2. Required number 1, find the missing value k and define the cumulative function CPF and draw. Of course, x is a discrete random variable and it's given the probability mass function for x. It is defined the probability distribution of this random variable with a missing probability which is k, and of the first property of the discrete random variable, as we mentioned in the last video, that is the sum of all the probabilities for all k must equal to 1. So we have here that 0.1 plus 0.2 plus 0.3 plus k plus 0.2 must equal to 1. So we have that 0.8 plus k equal to 1. That means that k must equal to 0.2. So we have now that this probability missing k is equal to 0.2. Secondly, we can draw the probability mass function given, which is f small of x with x. And as also we mentioned in the last video, that this function is a discrete function having a value as the possible values of x, which is -2, -1, 0, 1, 2. And we can draw this random variable, this mass function at -2, the probability is 0.1. At -1, the probability is 0.2. And at 0, the probability is 0.3. And at 1, the probability is 0.2. And at 3, the probability is 0.2. So this discrete function drawn is called the probability mass function, and its sketch is a discrete function. Now to draw the cumulative function f of x, we can first define the cumulative function, and as we mentioned also in the last video, that the cumulative function output will be 0 if x is less than the first value of x here, which is -2, and then for any x between -2 and the next value, which is -1, the probability will be the probability of the first function, which is 0.1. And from -1 until 0, we will add the second probability, which is 0.2, so we reach to 0.3. So 0.3 here is 0.1 plus 0.2. And from 0 up to 1, we will have another jump with the probability that x equals 0, which is 0.3, so we reach to 0.6. And from 1, starting from 1 up to 2, before 2, we will adding the probability of 1, which is 0.2, so we reach 0.2, and greater than 2, we will reach to 1. So the cumulative function must start with 0 and end with 1, and having the jump in between. And if we sketch this function, the cumulative function, it will be a step function. At less than -2, it's 0. At -2, we have the first jump to reach to 0.1. between -2 and the -1 it is 0, and at -1 we will have the second jump to reach to 0.3, and from -1 to 0 it's 0.3 again, and then at 0 we will have the next jump to reach to 0.6, and again it is constant until the next value, which is 1, and we will have a jump to 0.8, and finally the final jump at 2 to reach to 1 and remain as a constant value. So it is a step function. Each step is happened at the possible values for x, -2, -1, 0, 1, 2, and each jump is happened with the probability of this value. Required number B in the same problem. Find the probability that absolute x is less than 1 and evaluate the expected value of x and the variance of x. So the probability that the absolute value is less than or equal 1, that means the probability that x is between -1 and 1, and as we deal with a discrete random variable, x between -1 and 1 having only one possible value, which is x equal to 0, and from the probability mass function of the probability distribution table given, this probability is equal to 0.3. And to calculate the expected value of x, or mu, it is the average probability or average value of x weighted with its probability. So it is equal to -2 times its probability 0.1 plus -1 times the probability 0.2 plus 0 times its probability 0.3 plus 1 times its probability, which is 0.2, plus 2 times the probability, which is equal 0.2. So the value of the expected value will be equal to 0.2. Then to calculate the variance of x, or it's named as sigma squared, it is the expected value of x squared minus the expected value of x all power 2. So it is equal to -2 squared times 0.1 plus -1 squared times 0.2 plus 0 squared times 0.3 plus 1 squared times 0.2 plus 2 squared times 0.2. That is the expected value of x squared, each value squared times the probability, and finally minus the mean value we calculated squared. So we have the variance of x, which will equal to 1.56, and finally the standard deviation is the root of the variance, so it will be equal 1.25. Required number C for the same problem. If we have the random variable z, which is equal to 2x plus 5, find the expected value of z. And if we have another random variable y, which is equal to x squared, find the expected value of y. So we now spoke about two random variables. Let's say speak about the first random variable z. But the random variable z has relation with x with 2x plus 5. And of course, from this relation, we can get the possible values of z, because if x is equal to -2, that means that z will equal to 1. And if x is equal to -1, that means that z is equal to 3. And if x is equal to 0, that means that z equal to 5. X is equal to 1, z will equal 7. And x equal to z will equal 9. So the possible values of z is only happened when one of the possible values of x happened, because z is related perfectly with x. So when x equal a certain value, that make for sure z equal a certain value. So the value of z is perfectly depend on the value of x. And to get the probability function of z, we can use the table of x, because the probability that z equal to 1 is equal to the probability that x equal negative 2. Because the event that z equal to 1 is only happened when x equal negative 2. And from the table given, this probability is equal to 0.1 and so on. This will be 0.2, 0.3, 0.2, and 0.2. Now we can calculate the expected value of z, because it will be 1 times 0.1 plus 3 times 0.2 plus 5 times 0.3 and so on until 9 times 0.2. And of course this value will equal to 5.4. Now what about y? Y in this problem is defined by x squared. Y is a random variable, also depend on x, but it's not a linear dependent relation. So we need first to check the values of y from x. So as we have the relation x squared, that's mean when x is equal negative 2, that means that y must equal to 4. So the first possible value for y is 4. When x is negative 1, y will equal to negative 1 squared 1. When x is equal to 0, y will equal 0. And again, when x is equal to 1, y will equal 1. And x equal negative 2, y will equal 4. So the only possible values for y is 0, 1, and 4. To calculate the probability of y, of course, the probability that y equal to 0 is the probability that x equal to 0, which is 0.3. The probability that y equal to 1 is the probability that x equal negative 1 or x equal 1. That's why we need to sum the both values of negative 1 and 1 for x. So we have 0.4. And finally, the same for x equal 4, y equal 4, that happen when x equal 2 or negative 2. So that's 0.4. Finally, the expected value of y will be 0 times 0.3 plus 1 times 0.4 plus 4 times 0.4, and we can get this value for x. It will be, I think, 2. It will be 2, so the expected value or the average value of y is equal to 2. Let's see another example. If you have a hand of 4 cards out of the standard deck, and let x be the number of aces in the hand, what is the expected value of x? In this example, our experiment that we have hand of 5 cards out of the standard deck, which is 52 cards, and our random variable x is the number of aces in the hand. And of course, if we need to have the probability distribution of this discrete random variable, that x may be 0, that means that our hand have 0 aces, or x can be 1 or 2 or 3 or 4. That's the maximum number of aces out of our hand is 4 aces. And we need also to calculate the probability for each variable, because the expected value of the random variable is the summation of each value times the probability of each value. So to calculate the expected value, we need this probability distribution, and also we need the probability for each value of x. But now the probability that x equals 0, that means out of the hand of 4 cards, we have 0 ace. And using the counting, the probability of this value, it will be the probability of this event over the sample space. And of course, the sample space is 52C4. And the probability of having 0 ace is 4C0 times 48C4. And the probability that we have 1 ace is we have 4C1 times 48C3 over 52C4. Probability that we have 2 aces, we get 2 aces out of the 4 aces, and then 2 cards from the other card, not aces, over 52C4. And again, we have 3 aces, 4C3 over the sample space. And finally, we need to have 4 aces, and this nothing from the other card over 52C4. So the expected value of x now will be 0 times this value plus 1 times this value plus 2 times this value plus 3 times this value, finally plus 4 times this value, and the expected value of x will be, finally the expected value, it will be about 0.31 aces. As we see, to calculate the expected value of this discrete random variable, we need to define the probability distribution, or the probability of each possible value for x. And to define this probability, we understand the experiment at which x comes from, which is having a hand of 4 cards out of the standard deck. And out of this experiment, we calculate using the counting technique how to calculate the probability of each possible value. And then finally, using the rule of the expected value, we calculate the expected value of x. And of course, you can think that for each value of x, we calculate its probability, and then using the table, we get the expected value. For a certain discrete random variable with certain condition distributions, we have a direct rules to calculate the probability, and also a direct rule for the expected value without using this summation. And these discrete random variables are called special distribution random variable. And we will discuss some of these special distribution random variable in the next videos, like the binomial, geometric, negative binomial, Poisson distribution, and so on. Thank you.